Hello everyone, welcome to Daily Leetcode Challenge. So the problem for today is House Robber 2. So let me simplify the description for you. So there are n number of houses in a circular path. So the first house will be adjacent to the last house. So they are in a circular path. Now there is a robber who is going to break into all these houses and get some money. So there is only one condition that he cannot break into any two adjacent houses. So he has to follow this condition and maximize his amount of money that he can get from breaking into all these houses. Okay, so let's look at the examples to get more understanding about the problem. So in the first example we have three houses. So that means all the three houses, so because they are in a circular fashion, they are in a circular path. So if you take any two houses, they will be adjacent. That means every house is adjacent to the other two houses. So he can at max break into only one house. So the answer here will be the second house. So in the second example we have four houses. So there are two choices here. So he can start from the first house. So skip the second house because they are adjacent. Then take the third house. So the value here will be 1 plus 3, 4. Or he can start from the second house, skip the third house, then go into the fourth house. So the value here will be 2 plus 1, 3. So the maximum of 2 is 4. 4 is the value that you can get maximum. The next example we have only one house with value 0. So the answer is 0. And the constraints are like the number of houses will be in the range of 1 to 10, 1 to 100. And the value in the house, each house will be in the range of 0 to 1000. So the current constraints are not huge, so any approach should be okay, even brute force should be okay. But this is a bit tricky problem, so solving with brute force will be a bit complicated, and we may miss some particular cases to handle. So let's look at the hint given here. Since house 1 and house n are adjacent, so when there are n houses, the first house and the last house are always adjacent. They cannot be robbed together, so therefore the problem becomes to rob either house 1 to house n minus 1. So we can rob from 1 to n minus 1 or 2 to n. So we skip the first house or the last house, depending on which choice offers more money. So looking at the examples and the hint provided here, so at a first glance it may look obvious that we can do two things here. One is you can break into all the odd numbered houses and calculate the value. Then you can break into all the even numbered houses and calculate the total value. Then take a maximum of these two. This looks simple, but it may not work for some cases. Let's look at one tricky example to get a better understanding. Let's say we have 5 houses, so with values 3, 1, 1, 4, 1. So if we start from 3, so we have to skip the second house. So then we go to third house, so 3 plus 1, 4. Then we skip the next house, and we have to skip the last house as well because it is adjacent to the first house. So you get a value of 4. So let's check the other one, breaking into even numbered houses. So now we start with second house and skip the third house because it is adjacent. Then you go to fourth house, so 1 plus 4, 5. So a maximum of 5 and 4 is 5. But if you follow a different approach, you get even a better value. So let's start at 1, and you have to skip the second house because it is adjacent. Then the third house, here you have a choice whether you can break into this house or you can skip it, because the value is very less, and if you skip this house we have an opportunity to maximize our value because the next house has a value of 4. So we can skip the even the third house, so then break into the fourth house. So 3 plus 4, 7. So we get a maximum value of 7. So the principle here is at any given state, let's say at ith step, you can decide whether to include the current house, ith house, or not, depending on the maximum value that you have got so far in the previous two steps. That means for every step you maintain the max value till the previous house as well as previous to previous house. So you maintain maximum value for the previous two states. Then based on those two values, you decide whether to include the current house or not. So that is the principal step here in this. This is basically a dynamic programming. So that is the main principle here. So let's look at the source code to get more better understanding. So I have written a utility function calculate max value. So it will have the values for every house. Then we pass start and end. So it's like we follow the hint provided. So we calculate value from the first house to n minus 1 house. Then we calculate value from second house to nth house. So then we take maximum of these two. So the start here will be either the first house or the second house. Then the end with here will be either n minus 1 house or nth house. So the max current here represents max value till I minus 1 step. That means the maximum value that you have got till the previous house. Then max previous represents the max value that you have got till I minus 2 step. That means the previous to previous house. So then we start from the start house till the end. So we check for every house whether to include the current house or not based on the previous two values. So at any given step I, the current house cannot be added to the previous house. That means the previous value that you have got so far is max current. Max current represents the maximum value that you have got till the previous house, and here represents the maximum value that you have got till the previous to previous house. So when you are at the current house, you cannot combine that with the previous house, because previous house and the current house will be adjacent. So you can add the value of current house to the max previous, which is 2 steps behind. So you get the current value. Then you decide whether the current value is more than the previous max value that you have got. So previous max value is nothing but max current. So you take maximum of previous max or the current value, so that you updated in the max current, and the max previous becomes the max current, because now when you go to the next step, the max current becomes 2 steps behind the current house. So this way you update everything, and you finally get the max value when you process all the n houses. Then you return the max value, and then in the main function there are two base cases. When your number of houses is 0, you just return 0, and if number of houses is 1, you return 1. Then there are two things here that as we discussed. So you start from 0, that means the first house, then you go till n minus 1 house, or you start from the second house and then go till nth house. So you calculate the max value for both the cases, then you finally you return a maximum of these two. Yeah, so this way you get a max value instead of just following odd numbered and even numbered. So yeah, so that's it. And in case if you have any doubts, you can one thing here, you can try one thing. You print max previous and max current at every iteration, so that gives you a better understanding of the execution of this step. So that makes things even more clear. Yeah, so let's execute and see. These are some of the examples that I have created, so feel free to run through the function and check the max previous and max current values. Yeah, so these are the examples, and these are the our answer 3, 4, 12, 15, 3, 7. So it is matching 3, 4, 12, 15, 3, 7. Yeah. So let's submit and check the runtime. Yeah, so runtime is 0 milliseconds because we just process all the information only once. So it is a O of n solution, and the memory usage is also a constant, that is O of 1 space, because we don't use any extra memory. So the solution is O of 1 time complexity and O of 1 space, and all the test cases have been passed. Yeah. So thanks for watching. Yeah. Please do provide your feedback. Thank you.